this video, we're going to look at random variables, certain random variable distributions, and then we're going to do this practice problem to help us understand all these concepts. So let's just jump straight into the problem. So we have here the random variable x equals the number of computers sold in a randomly selected electronics shop. The variable's probability distribution is shown below, or maybe I should say shown to the right here. Sketch the probability distribution, then calculate and interpret the mean and standard deviation of x using the given context. So again, what they're asking us to do here is calculate and interpret mean and standard deviation of this random variable using the given context. Remember that context is everything when we're talking about statistics problems. If we don't include context, then our analysis is really meaningless, right? So we want to include what we're talking about. So this random variable distribution here, the first thing you should be thinking is that I have a 0 computer, 1 computers, 2 computers, 3 and 4. Do I see any values in between? And the answer is no. So right away, this should tell you that this is a discrete random variable distribution. And what does that mean? Well, that means this random variable can only take on fixed values, right? It can only take on fixed values, and I like to describe them as dots, right? There's gaps in between. You can only have integer number of computers, right? It's not like I'm selling 0.4 of a computer. I don't think anyone would want that anyways, right? So this is a discrete random variable. And when we're sketching the probability distribution, we know that we're going to have to use bar graphs. All right, so let's just jump straight ahead into the probability distribution. But before we do that, as mindful statistic readers, we know that probability distributions should add up to 1. So we know that all of these probabilities, if we add them up together, should equal 1. So if you want, you can go ahead and pull out your calculator. Just go ahead and add these up together. 0.145 plus 0.165 plus 0.239 plus 0.21 plus 0.241, and it does equal 1. So right away, we know that we're dealing with some legitimate probability distribution, right? So then we can just go ahead and go on with our problem. All right, so it's asking us to sketch this probability distribution. So again, I can list in axes here. I know my highest value is about 0.24. So maybe I can have a 1 and a 2 and maybe a 2 point, maybe a 1, 2, and 3 here. That would make more sense. And then that's 1.5, then that's 2.5, that's 0.5. All right. So let's just go ahead and create our bars. This is discrete, so we're going to have bars for all of these specific values. So for 0 computers, that's 0.145. So that is going to be fairly small here. Okay, and then for 1, that's 0.165. So that is, sorry, this was supposed to be, makes more sense if it's 0.1, 0.2, and 0.3, right? So again, this one is 0.145, so I should probably do this one again. And then for 1, it's 0.165, so it can be somewhere over here. And then for 2 computers, it's 0.239, so maybe somewhere over here. And then 3 is 0.21, so probably lower than that. And then for 4 is 0.241, so you can say it's a bit higher than that. Second computer. All right, so as you can see, this is not perfect. Remember, it says to sketch the probability distribution, so we shouldn't spend much time trying to find the exact axes values because that's not what they're asking. We just have a rough sketch of what this distribution looks like. Now let's get on to the numbers here. So we're asked to find the mean. Before we even get started, what does the mean really mean? Well, the mean is the expected value. In probability distributions, it's also known as E of X. That is, in fact, how most of the textbooks or worksheets will write that. That just means the long run expected value of this discrete random variable. So we're dealing with the discrete ones. We know that we're going to have to calculate this long run average. And how do we calculate that? Well, we take the sum of our specific values the variable can take. We denote that by x of I. That's the specific values like 0, 1, 2, 3, and 4. And we multiply that by the probability of all of these specific values. So that's the probability of these specific x of i's. And we take the sum of that, and then that is our weighted average. So we can go ahead and calculate that. So we can say 0 times the probability of that 0 computer occurring. So 0.145 plus 1 times 0.165 plus 2 times 0.239. And we're just going to add all of these products together where we're multiplying that specific event and that probability of that event occurring. Or maybe I should say that value occurring. All right, so I have all of these products listed out. You can go ahead and calculate all of these if you think it wouldn't take that much time, or you could go ahead, go into your scientific or graphing calculator, and if you edit your lists and put in these values, maybe you can put in computers as your list 1 and probability as list 2. If you want, you can even pause the video and go ahead and do that. And then after you've entered these values in, if you click on, I have a TI-84, so it should be similar. If you click on the stat button and go down to the second column, which is calculate, you should click on number 1, which is one variable stats. The list has to be where you put the computers in, so I put that as list 1. And the frequency list is the probability of that event occurring. So that's going to be the probability where you entered those values in. For mine, it was list 2. All right, so your list should be L1, frequently list should be L2, or wherever you put the computers in the probability, and then you click calculate, and it shows us that the expected value, like the E of x, that's 2.237. Now, what are we dealing with here? That's computers. We want to go ahead and write that as our unit. So that is our mean. Now, don't just leave this here as your answer. We want to interpret the mean in context, right? So again, the mean is the long run average. So if I were to take many, many repetitions of this specific event, then on average, then the expected number of computers that would be sold would be this mean. So let's just go ahead and convey that in words. So we can say if many, and we're dealing with computers here, computers in a randomly selected, and this is an electronics shop, were selected, or we can say were chosen if we don't want to repeat selected, then the expected number, right, expected value, expected number of, let's say here it's computers, would be on average, right, this is an average estimate, would be on average about, we can say that we have to repeat this means, that's going to be 2.237 computers. So here we've discussed all the important parts of the mean, right? We have the many, many computers. This is in the long run, so many, many repetitions. We have randomly selected. Then the expected number of computers would be about this amount. So that looks like a pretty solid interpretation to me. All right, so let's just go ahead and finish the problem up by finding the standard deviation. So standard deviation can get a bit tricky sometimes, but we just need to look at what this is describing. What is standard deviation? Well, in the term itself here, I see deviation, right? So it must be some measure of spread that tells me that I'm deviating from a certain value. That's going to be the mean. So the standard deviation is a measure of spread. It tells us that if we were to repeat this process many times, then the number of computers would typically differ from the mean by this amount, right? So we're seeing where basically the formula for standard deviation, we're going to denote that using sigma of x. That's going to be our square root, and we're going to find the sum of the deviations of certain events from the mean. So it's just going to be x of I minus the average. That's going to be a mu of x. We're going to square these deviations, and remember that this is weighted, so we're going to have to multiply that by the probabilities. All right, so as you can see, it's a bit similar to the mean. We're multiplying both of these by the probabilities, but since this is the deviation, we have to find how certain values deviate from the mean, square that, multiply that by the probabilities, and then take the sum of all those products. It's not very confusing, but we can still try to interpret that. All right, so how do we show our work for this? Obviously, we don't want to show the product of every single value 0, 1, 2, 3, 4 here. We can only show the first one and the last one, and then that would be sufficient work. So over here, the first value that the variable can take is a 0, right? 0 computers sold. So 0 minus the mean, well, that's just going to be 2.237. We're going to square this deviation. We're going to multiply by the probability. The probability is 0.145. And that's our first product. And maybe we can put a plus sign. We can put some ellipses for all these middle ones. And then we're showing the 0, the first, and the last. So that's just going to be 4. We take on a value of 4. 4 minus 2.237. We square this deviation. We multiply by the probability 0.241. All right, and this would be sufficient work. This is a very nice formula for the standard deviation. Now, instead of calculating that, there would be a lot of work. We can just go back to our calculator output, and it shows us that sigma of x is 1.365 computers. So that is its typical deviation, right? And again, I want to emphasize that this is long run. Each of these, the mean is long run, the standard deviation is long run. This is not a one-time repetition, right? This requires many, many repetitions. That's how we can even get this value in the first place. All right, so now we want to interpret this. Remember that this is a typical deviation. So we can say here that the number of computers sold will typically, see, I'm using keywords here, like typically differ. And what are we typically differing from? Well, we should just look back at the formula, right? There's nothing to memorize. It's all about understanding here. We're typically differing from this mean. This is that deviation. That's why the mu of x is including here. So we'll typically differ from the mean number of computers sold. And just for clarification, maybe we can even include that this mean number is 2.237 computers. So the number of computers sold will typically differ from the mean number of computers by, on average, right? This is long run, that's going to be the 1.365 computers. And if you want to be extra clear, you can just include in the long run. All right, so over here, similar for the mean, we included keywords here. The number of computers sold will typically differ from the mean, right? We're differing from something. That's going to be the mean. From the mean number of computers sold by, on average, about 1.365 computers. That's actually our standard deviation. All right, so I know this was a lot of words to interpret, but the main thing is that we want to understand these processes and how these measures of spread and that typical expected value tells us something about the distribution. And you may be questioning that why are we even studying this? What is the use of random variables? Well, really, random variables are a basis for inference tests, hypothesis tests, and they're just certain fundamental concepts that we need to better understand these random processes and even their results. Are these results unlikely? Are they likely? Are they statistically significant? Right? We can make much more meaningful conclusions with this knowledge that we have here. If we know to properly analyze, if we know to properly look and understand and interpret all these measures, then of course we can make much more meaningful conclusions about the random data that we see, and that's going to be much more useful in the future. Alright, so if you like this video, please be sure to give it a thumbs up. If you think that any other students or friends could benefit from this, be sure to share it with them. If you have any questions, put them down in the comment below. Subscribe to my channel, and I'll see you next time. Bye!